Right. Look at this one. So block of mass 10 kg is put gently on the belt conveyor system of infinite length. So this is a conveyor system like which is just going to, you have a belt over here which is rotating, right? And they are saying that length of this is like infinite here, right? Which is moving with a constant speed of 20 meters per second towards right at all the time. That means this belt over here, you see, this belt here is always moving towards right with a 20 meters per second. Okay, then so by means of a motor in the system as shown in the figure, right? A constant force of magnitude 15 newtons is applied on the block continuously during its motion. Now answer the following questions they are saying, right? They gave mu s is equal to 0.4 and mu k is equal to 0.25. Kinetic friction, coefficient of kinetic friction and static friction are given to you, right? Now, the nature of the frictional force acting on the block of mass 10 kg during its motion is. Now you see here, you have some kind of a platform here or belt which is moving with 20 meter per second. Now, this is your 10 kg. Can you tell me what is the static frictional force here equal to what is the maximum static frictional force it can have? That is mu s into mg. How much is that? 0.4 times mg. Take g is equal to 10 here. Okay, then that is equal to, you will get 40 newtons. That means unless and until you apply a force more than 40, this is not going to move. This is not going to move in the sense it will move with a 20 meter per second only, exactly 20 meter per second, right? But then there will not be any relative slipping over here. Clear? With respect to the belt, it is not going to move, right? It will just move along with the belt. Now, what is your maximum kinetic friction here? What is maximum kinetic friction? That is all. That is your you will get 25. 0.25 into 100. You will get 25 newtons. Clear? Now, your applied force is your 15 newtons only. If applied force is 15 newtons and the block is at rest with respect to the belt, right? That means what is your frictional force acting here, over here? 15 only. Whatever is applied force, that will be your frictional force, right? And what is this here? Nature of the frictional force, that will be static. Clear? Just don't write that just because block is moving here, that won't be a kinetic friction. Clear? It will be static only unless and until you have a relative slipping between the two surfaces here, then only we should say that it is a kinetic friction. Otherwise, it is static. Clear? Let's go for the next question. So same scenario, and they are asking work done by a kinetic friction on the block of mass 10 kg is. Where is the kinetic friction here? Where is the kinetic friction here? We don't have any kinetic friction here, right? We don't have any kinetic friction over here. Okay, let us see what is the work done by the frictional force over here on the 10 kg block. So 10 kg block over here. So on the 10 kg block, your friction force exactly equal to the 50 newtons will act in the backward direction, right? And it is going to get displaced. It is going to get displaced in the forward direction. One second. Is it dropped over here? This one? By means of a motor of the system as shown in the figure, constant force of magnitude 50 newtons is applied on the block continuously during its motion. Answer the following questions. Okay, look here, this we missed this point. So this is, they said it is put gently on the conveyor belt moving with a, I mean like moving belt over here, which means if I just gently put it, what is its initial velocity? What is its initial velocity? Initial velocity is 0. I'm just gently putting it, right? I'm just gently putting it. If you just gently put this one, look over here. This is a platform which is already moving with 20 meter per second. Okay. So now if I just gently put this one in the sense, that means its initial velocity is 0, right? For some amount of time, so this will be like, this will slip on this one because its velocity is 0, but then this point is moving with a velocity of 20 meter per second. That means the point over here will move forward. That means this will be pushed backwards, right? With respect to the belt, it will move in the backward direction here, right? So then in that case, you have your, what is the nature of the friction over here? Kinetic friction. Try to understand. I have a belt which is already moving with some velocity, right? If I place a mass over here with some velocity, sorry, with gently placed over here, then it will just, its initial velocity is 0, right? But then still it is still moving forward here. With respect to the belt, your block has actually come back. Why it will be at rest? Okay. Okay, this is moving forward with respect to this belt. I am asking. Okay, let me say this. I'll mark some point over here. Let me paint some. Let me put some marking over here on the belt. Right now, after some time, let us say that this marking has reached this location. Where will the block be? Somewhere over here. Somewhere over here, right? What is the reason? Because as soon as this is like, if one point is like, this point is having a 0 velocity and other point is having 20 meter per second, that means they are slipping. Correct? There is a relative slipping here. If relative slipping is there, then what kind of friction will act? Kinetic friction will act. Clear? On the block, kinetic friction will act. So on the block, and in what direction the friction will act here? In what direction the friction will act here? With respect to the belt, what is the velocity of the block? Backward. Understood? With respect, you see here, on the ground, if I try to push the block in the forward direction, that means with respect to the ground, it is moving in the forward direction. If with respect to the ground, if it is moving in the forward direction, friction on the block will act in the backward direction. Now, with respect to the belt here, what is the velocity of this one? This is the velocity of the block with respect to the belt, right? If this is the velocity of the block with respect to the belt, then friction on the block should be acting in the forward direction. Understood? So this is your kinetic friction. Clear? So now, if kinetic friction is acting on the right, mu k into g. Now, if it is having acceleration in the forward direction, that means in the forward direction, its velocity will increase. In the forward direction, its velocity will increase, right? So, in the forward direction, if velocity increases here, that means at one particular instant of time, this block also will attain a velocity of 20 meter per second. Clear? And as soon as the block also attains a 20 meter per second, right? This platform is also moving with 20 meter per second. So they both will, now they both are moving together. If both of them are moving together, then where is the question of friction here? Unless and until you apply any force on this one. Clear? Unless and until you apply any force on this one. Clear? So now your what do you call this? So your friction is going to be, initially it is kinetic in nature. Initially it is kinetic in nature, and then as after it attains a velocity of 20 meter per second, then the friction changes to static friction. Understood? Clear with this? Right. So which means the answer for the what is this question? Yes. So answer for this question is sometimes kinetic and sometimes static. Clear with this? Right. Okay, look at this one. So work done by the kinetic friction on the block they are asking. Right. What is the, on the 10 kg block, your kinetic friction is acting in the forward direction, along with this there is another 15 newtons also acting here. Correct? Right? What is this kinetic friction force equal to? 25 newtons we got. Correct? What is the acceleration of the block here? What will be the acceleration of the block? Total 40 newtons acting on the 10 kg block. So it will be 4 meter per second square. Correct? And initial velocity is 0. After some time, once its velocity becomes like 20 meter per second, this kinetic friction will become 0. Correct? This kinetic friction will become 0 here. Then, so that means your final velocity is 20, and I need what is the displacement here. So which equation of motion you will use? A square minus a square equal to 2as, right? So this is your 20 square is equal to 2 into a into s. So how much is this here? S, you will get this equal to 50 meters. Okay. So your displacement in the forward direction, kinetic friction is also in the forward direction. What is the work done by the kinetic friction here? 50 into force into displacement directly, right? So that is your 1250 joules, and this should be positive work done, right? So it is option A. Clear with this? Right? Now you should not count this or this also into the while calculating the work done, because they ask only due to the kinetic friction. But while finding the acceleration, you should consider this. Understood? Right. Look at this one. Magnitude of the acceleration of the block of mass 10 kg at t is equal to 6 seconds. At t equal to 6 seconds. That means over here we should get at t equal to 6 seconds, is the friction kinetic in nature or static in nature? Okay, that you have to decide first. How will you get that? How will you get that? Again, using the same variables. U, V, A. What is the time here? How much time it takes to attain this 20 meter per second here? T is equal to 5 seconds. That means only up to 5 seconds your kinetic friction will act. Then what will happen? Only static friction will act, right? If static friction is acting, what will be that static friction equal to? 15 only. 15. If that will be, if applied force is less than the limiting friction, then it is your static friction is equal to applied force. Correct? So now what is the acceleration over here? What will be the magnitude of acceleration of the block of mass 10 kg here? 15 newtons is applied on this. Again, static friction exactly equal to 50 newtons will act on this. What will be the acceleration? 0. Why you are getting confused? Not understood? Should I repeat this again? Huh? At t is equal to 5 seconds, what is happening? What is happening? Block is moving with 20 meter per second and belt is also moving with 20 meter per second. Correct? So nature of the friction over here will become static friction. Correct? Nature of the friction will be static friction. And what is that static friction is equal to? That means like with respect to this one, it is going to be just at 20 meter per second only. It will not further increase its velocity here, right? After t is equal to 5 seconds. So I am applying 50 newtons here. Exactly 50 newtons of static friction will act on this one, right? And acceleration of this block will be equal to 0 from t equal to 5 seconds onwards. Clear? So this will be option D. Understood? Right? Up to t equal to 5 seconds, acceleration will be 4 meter per second square. From t equal to 5 seconds, it is 0. Clear? Right. Right. Look at this one. Wooden cube with a side d equal to 0.1 meters is placed on the horizontal support. A bullet of mass m is equal to 0.010 kg is shot vertically up through a right. It is shot vertically up through a support and through the cube. As bullet passes through the cube, its speed decreases uniformly from 120 meter per second to 115 meter per second. So minimum mass of the cube that would allow it not to lose the contact with the support is minimum mass of that block which will not allow to lose the support from the contact. That means like you have the block over here which is placed on some kind of support, okay, which is placed on some kind of support here, and you have a bullet over here, so which is coming with a velocity of 120 meter per second. Okay, they said that it is shot vertically up, right? What will happen? And then so they said that it is going to, so velocity has decreased to 115 meter per second as it comes out. Clear? Understood? Right. Which means what is the deceleration of the bullet or acceleration of the bullet over here? Correct only, right? So you take the side of the cube as did they give the side of cube? Okay, they have given that d which is equal to 0.1 meters. So this is equal to 115 square minus 120 square, v square minus u square divided by 2 times 0.1, right? How much is this here? Apply a plus b into a minus b. This is 235 into minus 5 divided by, this is 0.2. What is 1 by 0.2? 1 by 0.2 is nothing but 5, right? So multiply with just 5 here. Clear? Multiply with a 5 here. Just keep this. So this is the acceleration, or sorry, that we are having. Ideally, this is the deceleration. Okay, but who is causing this deceleration for the bullet here? Let us draw the free body diagram. When bullet is inside this block, when bullet is inside this block here, assume that this is the path through which the bullet is moving, right? Now, at the instant when bullet is at some location over here, let us say if I draw the free body diagram for the bullet. So bullet's velocity is in the forward direction, upward direction. So if it has to decrease its velocity, I should show its acceleration in the downward. Correct? So if it has to have an acceleration a in the downward direction, its mass is very negligible. I mean, like because of mg force, it will just have its acceleration g in the downward direction. But instead, this is a very high acceleration, right? So that means this block is actually applying some resistance force in the downward direction. Correct or not? Right? This block is actually applying some resistance force in the downward direction, and from your Newton's laws, you can say that equal and opposite amount of the resistance force will apply. Will this bullet also will apply on the block? Getting the point, right? Now, what is your resistance force over here equal to? This is equal to mass of the bullet into its acceleration, right? What is that equal to? Mass of the bullet is given to you. How much? 0.01 kg. And what is the acceleration? Magnitude of the acceleration. So this is 235 into 25. Clear? So this is the resistance or resistive force that the block is applying on the bullet, and the bullet also will apply equal and opposite amount of the force. Now, if the block should not lift up, okay, if the block should not lift up, you see here, this is the mg of the block here. If the block should not lift up means this normal reaction should not be equal to 0. Clear? Normal reaction should not be equal to 0. Now, what will be the equation for the block over here? In the upward direction, what are the forces available? N plus resistive force Fr should be equal to mg at any instant. So write N is equal to, this is your mg minus Fr. If I need the minimum mass over here, then I should put N also minimum. So minimum value for which, like N over here, should be equal to 0, right? So this is 0 is equal to, this is mg minus Fr here. So can you find out what is mass of the block required here? Yes, we already have the value of Fr. Substitute in this one, get the value of mass here. Clear? Copy this one. Noted? Done? Completed? Look at this one. So this is one very good advanced level question actually. A smooth ring of mass m can slide on the fixed horizontal rod. So where is it? This is the ring here. Ring of mass small m. So which can slide on this rod. Okay. Then a string tied to the ring passes through this pulley here, right? Fixed pulley B and carries a block C over here of mass 2m given to you. As ring starts sliding here, they're asking for acceleration of the ring, acceleration of the block, tension in the string, and if block descends with a velocity of v, then ring will slide with a velocity of how much? V cos theta. Okay, you have to decide which is the correct option, correct answer over here, right? So which method shall we adopt over here? They are not just asking the constant relation. If it is only the constant relation, then you can just write down string length and equate that to L and differentiate, double differentiate, you will get the relation between the accelerations, right? But they are asking like the what is the acceleration of ring, acceleration of block, and all those things. Yes, right. Now look over here. Let us say acceleration of the ring, since it can only slide on this horizontal rod here. So your acceleration of the ring, let us say I'll write it as a1 in this direction, right? And the block over here, it can move only in the downward direction. Let us say its acceleration is a2, right? Then let us assume tension in the string is some T here. Now carefully observe. A normal reaction from the ring here, but that is of no use. Okay. So what is the force acting on this ring over here in the horizontal direction? T cos theta, which is equal to small m times a1. Clear? Then for the block C, here you have a tension T and 2 mg in the downward direction. That's it, right? Then what is the equation for block C here? 2 mg minus T is equal to 2m a2. Clear? 2m a2. Now how many unknowns and how many equations do we have? 3 unknowns, a1, a2 and T, right? And only 2 equations we have. What is the other equation that we should bring here? Constant equation. Clear? Constant equation which gives us the relation between a1 and a2. Okay, let us write down that equation here. Now let us say this height is not going to change, right? This height will not change. Let me mark this height over here as some h. Okay, then let us take, so from this I said that from a fixed reference you have to mark the positions of the moving objects, correct? So I'm taking this vertical line over here, right, as one fixed reference here, and this is here, I'm writing this as x1. Okay, then this is also a horizontal level at the pulley, right? At pulley level is also another my fixed reference here. So from here I'm marking the position of this one, block C, which is x2. Clear? I have marked all the positions of the moving objects here. Now what will be the string length here? Tell me. Total string length L is equal to, what is this length? What is this length equal to? Under root of x1 square plus h square. So this is under root of x1 square plus h square plus what is this vertical length here? X2. Clear? Let us differentiate this one here. So if you differentiate once, so you'll get this equal to 1 by 2 root x1 square plus h square into h is anyways constant. Differentiation of this will become 0, and this will be 2x1 into dx1 divided by dt. Clear? Plus this is here dx2 divided by dt. Right? Now carefully observe here, dx1 by dt. Let us say if I mark the velocity of this one, they have given some point over here based on the velocity. If block descends with a velocity v, then ring slides with a velocity of v cos theta. Let us see if this is the equation for velocities here. We can decide on this. See here. So assume that this is your velocity of the block and velocity of the ring over here, right? So what is velocity of the block equal to? Velocity of the block and x2 say I took in the same direction, and vr and x1 I took in the opposite direction here. That means in place of dx1 by dt, I should write minus vr. Clear? Right? Minus vr. So this is here. In place of dx1 by dt, I should write minus vr. And in place of dx1 by dt, I should write vb. Clear with this? Right. Now it is very simple here. 2 gets cancelled. What is x1 by under root of this length here? x1 divided by this one is cos of this angle here, right? So let us write on that. So this is here minus vr cos theta plus vb equal to 0 here. So you'll get vb is equal to vr cos theta. You see here? Does this is this correct here? Block descends with a velocity v. This is velocity of the block is v. Then ring descends with a velocity of v by cos theta. Velocity of the ring is equal to vb divided by cos theta. Velocity of the block, if block descends with a velocity of v, then this should be v by cos theta. Clear? So this is incorrect. Clear? Now we need the relation between the accelerations over here. If we need the relation between accelerations, let us take this equation and continue ahead. Okay, so what is this equation? Just try to just remember this one. This is x1. Tell me the equation. x1 by under root of x1 square plus h square into dx1 divided by dt plus dx2 divided by dt. That should be equal to, clear? Now second time differentiation over here. Right. So second time differentiation, what do you get here? Now you have to differentiate this term also here. Right. So let us say you differentiate this one. So you get, I think this is getting options low. Theta is changing, Adamma. If theta is changing here, right? You should differentiate that also. Clear? Theta is changing over here. Now look over here. First, let us differentiate this. Like take the UV formula here. Okay. So first, let us differentiate this one. So you'll get d square x1 divided by dt square into, right? I'm directly writing this cos theta. Then plus. Now you keep the dx1 divided by dt as it is, and d by dt of all this thing. I'll come to this, right? I'll come to this point. Initially, what is the velocity of the ring here? A smooth ring of mass m can slide on a fixed horizontal rod. String is tied to the ring and passing over a fixed pulley and carries blocks E of mass 2m as shown in the right. Read this point. As the ring starts sliding in the sense, what is its initial velocity? 0. Understood the point, right? So its initial velocity is 0, right? Where is this? So its initial, if its initial velocity is 0, then whatever may be the differentiation over here, this is 0. Correct or not? dx1 by dt at a time t is equal to 0, this term will become 0 here. Understood? Right? So then plus this is your d square x2 divided by dt square equal to 0. Clear? So now this is your, what is the d square x divided by dt, d square x1 divided by dt square minus acceleration of the ring into cos theta. I think many people are having doubt in this portion. I'll take that. This is acceleration of the block here is equal to 0. So you'll get acceleration of the block is equal to acceleration of the ring times cos theta. Acceleration of the, I think I've taken this as equal to a1 and a2, right? a1 a2 తీసుకున్నాం కదా, we took them as a1 and a2. So this is a2 is equal to a1 cos theta. Clear? Now look at this part here. You see this cos theta over here is not fixed here, because theta is varying here, that will change, right? At what instant we are doing this analysis here? Initially at a time t equal to 0, right? At time t equal to 0, that inclined string is making an angle theta with the horizontal, right? At that instant, right, I'm differentiating this one. See, this is at t equal to 0, this is equal to 0, this term equal to 0, right? But then you can differentiate this one over here, but while final substitution here, this anyways will be 0. Clear? Which means whatever may be the differentiation over here, since this term is 0, this complete term will become 0 here. Understood now? So you don't have to again differentiate all this and like write the big equation here. Is that clear? Right? Yes. If initial velocity was not 0, then that will be a very big calculation. Clear? Right. So you got a2 is equal to a1 cos theta. What were the two equations that we got? So one is t cos theta is equal to ma1 for the ring, and for the block 2mg minus t is equal to 2ma2. Clear? And what we need to find out all the unknowns over here. So let us do it one by one here. So in place of t, what can you write here? This is 2mg. In place of t, you can write ma1 divided by cos theta, which is equal to 2ma2. Cancel the mass m over here in all the terms. Then in place of, let us remove the a2 here. In place of a2, write a1 cos theta. So this is your 2g is equal to, take this onto the side, this is your a1 divided by cos theta plus 2a1 cos theta, right? So what is your a1 from here? What is your a1 from here? Take a1 common, and this is 2g divided by 2 cos theta plus 1 by cos theta. Clear? Which you can write this as, take cos theta as LCM. So 2g cos theta divided by, you'll have 2 cos square theta plus 1. Clear with this? So once you get a1 here, what is your a2? a2 is equal to, you just have to multiply with one more cos theta to that term, right? So which is your 2g cos square theta divided by, this is your 2 cos square theta plus 1. Understood? Clear? Then how do you get the tension here? From this one, right? We have a1 value here. So tension T is equal to, this is m a1. So m times, so you have to multiply this term with the m and divide with cos theta, right? This cos theta will go over here. So then you will get 2mg divided by 2 cos square theta plus 1. Now see which options are correct here. Which options are correct here? For ring, This is correct. 2g cos theta by 1 plus 2 cos square theta, right? Then for a block, it should be 2 cos square theta in the denominator. So this is incorrect here. Then tension, this is also incorrect. You should have 2 mg here. Correct, right? Yeah, 2 mg. So then only correct option is option A. Clear with this? Right. If you wish, you can copy this. Copy this one and individually start solving, continue solving the questions, and if you have any doubts, we can discuss. Any doubts in this question? If that's what I'm explaining here. I'm taking the velocity. This is the velocity of the ring. Okay, I got this equation. I got this equation which connects the velocity of the ring and the velocity of the block, right? Then if the block descends with a velocity v, this is not the initial velocity here. Understood? These are the velocities at some instant of time. Okay, at some instant of time, right? Vb is the velocity of the block at some instant of time, and Vr is the velocity of the ring at the same instant. At the same instant, then those two velocities will follow this relation. Understood? Yes. Ah. Basta.